Welcome learners to part 3 of complex number. First of all, clap for yourself because you have made it till part 3. In this part, we will be discussing more complex problems of complex numbers, and then we will jump on to the most favorite topic, Argand diagram and loci. So without wasting much time, let's start the class. The complex number u and v are defined u equals to this and v equals to this. Find u upon v in the form of x plus iy. All right. So what we can do in this case is I will just put it in u by v form. That will become minus 4 plus 2i upon 3 plus iota. Now we have to find our answer in this form. So what we can do, we can rationalize, right? This is how we divide complex numbers. There should be 3 minus I, 3 minus I, and then a plus b, a minus b. What is a plus b times a minus b? That is a square minus b square. But how, sir? See, a times a is a square. A times minus b is negative a minus b. Negative a times b, ab. Now b times a is positive ba and b times negative b is negative b square. See, these two terms cancel out because they are like terms. So we will remain with a square minus b square. Very important identity. Please do remember it and please do make it in your practice so that you won't lose your marks in your examination. Let's go now. This would become 3 square is 9. First solve the denominator and this should become negative I square. Now tell me what is the value of I square. I square is negative 1, sir. So negative 1 times negative, that would be positive 1. So 9 plus 1. And now let's solve the numerator. This would become negative 12, positive 4i, and 2i times 3 is plus 6 iota, and then 2i times negative I. Now, see, this is the most common mistake which usually students do. We have to multiply 2i times negative I. So see, I times I is I square. 2 times negative 1 is negative 2. I square is negative 1. Negative 1 times negative 2 will give us 2, that is positive. So always remember, be a little bit mindful when multiplying these terms. All right. So we will get this as negative 10 plus 10i upon 10. Divide 10 by both of them. So we will get negative 1 plus iota. Let's move on to the next one. Hence express u upon v in the form of r, that is the modulus, iota, e to the power iota, theta, theta is the argument. Very simple. We can find r because we know u by v equals to minus 1 plus iota. R equals to square root of negative 1 square plus 1 square. How, sir? Let me tell you. See this better. So if we have this axis, okay, so if we locate this point in the real axis, we have to go negative 1. In the imaginary axis, we have to go 1. This is the point. Was one way of locating the point. If I know the length, this length from the origin, and if I know the angle, can I just simply draw the length and rotate it at this angle and can reach to this point? Yes, sir, you can. You can, sir. So this is a second way of representing it. This is the exponential form of representing a complex number. All right. You have to find this r. See a right angle triangle. This is the hypotenuse. We are doing that only. R equals to square root of 2. We have to find this theta. But to find this theta, we have to find this alpha, and this alpha would be 10 inverse 1 upon 1, that is, don't put negative 1 inside, okay? I'm talking about the length. So never put negative inside. So this would be pi by 4. What is the value of theta now? See, theta is 180 minus this alpha. So theta is equals to, always in radians, pi minus pi by 4. That would be 3 pi by 4. Very good, learners. You got this one also correct. So our u upon v would be square root 2 e to the power iota times theta is 3 pi by 4. All right. Let us proceed to the next question now. In an Argand diagram with O the origin, the points A, B, C represent the complex numbers respectively. State the fully State fully the geometrical relationship between OA and BC. All right, let's try to understand this question first. Okay, first of all, we have to know OA. OA is U. We know OA is U. This is the position vector, right? OA is U. Position vector is the coordinate. Always remember this. Position vector is the coordinate. Remember, repeat, repeat after me. Position vector is the coordinate. Okay. Now, OA is U. All right. We have to calculate BC first. What is BC? BC would be OC minus OB. Yes or no? OC minus OB. All right. Whenever you're calculating the direction vector, always know this sign. Well, C is position vector, that is OC. Subtract from OB. All right. What is OC? OC. 2U plus V. Okay. So 2U plus V subtracted by OB. What is OB? OB is only V. So we will have BC equals to 2U. What can you see in these two? Just let me know that. Can you see that BC is the scalar product of OA? Yes or no? So if BC is the scalar product of OA, that means these two are parallel. So we can say that BC is parallel to OA. But BC has twice the magnitude of OA. So we will mention that as well. And twice, always mention this as well. And twice the magnitude. Simple, easy, understood. Show me a thumbs up then. Very good. Now let's move on to the next one. Prove. There are many ways to solve this question, proving question. I will use the argument one. You can use a different one if you want, but let's work. Let's go. Okay. I will teach you how to visualize. Don't worry. Stay with me. Take a deep breath. Now let's go. So we have to prove that angle AOB equals to 3 by 4, 3 by 4, 3 by 4 pi. All right. So if we talk about angle AOP, now what have we figured out over here? We have figured out that this is the origin. A is represented by complex number U. Okay. So let this point be A somewhere. Let this be A. All right. B is represented by complex number V. Okay. So let this point be V somewhere. We know A, we know U, and we know V, right? We know U, this is U, and this is V. Let me write down this. So U equals to negative 4 plus 2i and represent it with the real points. And V equals to 3 plus iota. Alright, let's move them. Let me memorize the coordinates only. This is negative 4 and 2, 3 and 1. Negative 4 and 2 and 3 and 1. Okay. So negative 4 and 2, and that was 3 and 1. All right. So this is A and this is B. We have to calculate the angle AOB and prove it to be 3 by 4 pi. Before targeting these type of question, draw this diagram. This is mandatory. This is mandatory, not a choice. Okay. Now listen. If I have to find this angle, this one, I know this theta. This is the argument of B. Yes or no? And I know this angle. This is the argument of A. If I subtract, if I subtract this from this complete, Will I remain with this angle or not? Think with me. Think with me. Are you thinking with me or not? So what will I do is I will subtract the of argument of A minus argument of B. All right? Argument of A, or we can call OA, and argument of B. Can we do that or not? Yes or no? So we will subtract argument of U minus argument of V. All right? So that would be argument of UV. Very good, learners. You got this one. And now, sir, why would it be argument of UV? That is the question. We are subtracting here, sir. And how can you write? How dare you write it like this? How dare you write it like this? Now, to understand this, first of all, let me answer it. Argument of UV was 3 pi by 4. See, look from here. It was 3 pi by 4. Argument of UV. Okay? And now you will say that, sir, we are subtracting the arguments. Then why have you divided it? Okay? To answer this, just open your ears and try to understand this one, what I'm talking about. Let u be in exponential form r1. I don't know the exponential form, I'm just writing. Think with me. Don't rush, think with me. Drop your pens. E to the power I theta 1. Theta 1 is the argument of, what is the theta 1 argument of? Yes, correct. It's argument of u. Okay? Now v be like this. R2 e to the power I theta 2. If I divide u upon v, it will become e to the power r1 e to the power I theta 1 divided by r2 e to the power I theta 2. Are you visualizing it with me? Are you or not? Nothing with me. Again, learners. Now, if the base is same, if I write like this, x cube upon x square, what do? You subtract the powers. 3 minus 2, x, it will become. Yes or no? This is the rule. This is the rule or not? So over here we will do same. The base is same. So I can write u upon v equals to r1 upon r2 e to the power I theta 1 minus theta 2. I would be common. I took iota theta 2. See, what I did was iota theta 1 minus iota theta 2. I took this iota common. Now, we want to calculate the difference between the arguments. Yes or no? Argument u minus argument v, which would be same as the argument of ub, because over here also we are subtracting the arguments. Can you see it or not? We wanted to calculate theta 1 minus theta 2. That was same as argument of u by v. Can you locate it over here or not? Argument of 1 minus argument of 2. This is this angle. Don't get confused. If you got confused in this one, pause the video, just go back, listen to it again, visualize it again, and then proceed further. Very good, learners. You made this far as well. Let us move to the next question now. Complex number u is defined by u equals to this one. A is a positive integer. Express u in terms of a in the form of x plus iota y. X and y are real and exact. Okay. Now listen. Same thing we will rationalize over here. The same thing which we do. So square root of 2 multiply by conjugate, that would be 1 minus 2 iota divided by 1 plus 2 iota times 1 minus 2 iota. Done. This one is done. Now this one would be again a plus b, a minus b. So it would be 1 square minus 2 iota square whole square. That would be 4 iota square. That would be negative 4. So our denominator would be, students, 5. All right. Now expand the brackets, this by this, this by this, this by this, this by this, and we will get square root of 2 minus 2 square root of 2 iota minus a square root of 2 iota minus 2 a square root of 2. Yes or no? Repeat after me, yes or no? Take the real terms to the one end and the imaginary terms to the one end, and we will get square root of 2 minus 2a square root of 2 plus iota and negative 2 square root of 2 minus a root 2. Separate the terms and you got the answer. So take the real part with 5 and it would give you square root of 2 minus 2 is square root of 2 upon 5 plus take the imaginary part upon 5, that would be negative 2 square root of 2 minus a root 2I upon 5. Got this, learners? Very good. Let us move on to the next one. It is now given that a equals to 3. Express u in form of this, where r is greater than 0, theta is between, always remember the argument is always between negative 180 to positive 180. Alright? Giving the exact value of r and theta. Okay. So our u was square root of 2 minus, if we put the value a equals to 3, it would become 6 root 2 upon 5 plus negative 2 root 2 minus 3 root 2 upon 5 iota. Okay. Now, now think with me. Square root of 2 minus 6 root 2. Will it give us negative 5 root 2 or not? Upon 5. Will it give it or not? Minus 2 root 2 minus 3 root 2. It will also give negative 5 root 2 upon 5 iota. Yes or no? Cancelled. Square root of 2 minus square root of 2 iota. Will it become like this or not? Just tell me. Can I find the value of r? We have already did. I have already explained how do we find it. So it would be negative squared plus negative squared, and then we will take a square root. So what is the value of r coming, my friends? It is coming 2. Alright. Now let's try to locate this point. Locate it first. Before finding the argument, locate it first. Both are negative. So negative over here, and this one is also negative. Square root 2, square root 2, negative, negative. This is the point which we have. Okay. Form a triangle now. Don't fast forward the video because you will learn new thing. Form a triangle. The base is also root 2 and the height is also root 2. We have to calculate this argument, negative theta we can say, because we are moving in clockwise direction. Okay, and we have to calculate this as well. We can call it as alpha. So tan alpha equals to square root 2 upon square root 2. Alpha equals to tan inverse 1. I told you never put negative in your calculator, okay? Remember, never put negative in your calculator because your teacher told you. Alright? Now, it will become 1 alpha equals to pi by 4. We have this angle as pi by 4. Okay? How can we calculate the value of this negative theta? What we can do is we can just subtract this angle by pi. So pi minus pi by 4. That would give us 3 pi by 4. And we know it is negative because we are moving in clockwise direction. So the value of theta would be negative 3 pi by 4. Okay? Done? Very good. You got this one also correct. So what would be our form? A form would be u equals to r e to the power I theta. That equals to r is 2. So 2 c 2 e to the power I. What is the value of theta? times by 3 pi by 4. Very good, learners. You got this one also correct. Let us move on to the next question. Are you guys excited or not? Now you are understanding complex number or not? I want to learn it. So please do let me know that in the comment section. Okay. I don't want to see comment section empty. These videos are made for you guys, right? All right. Using your answer to part B, okay, so we have u equals to, let me write down the answer, 2 e to the power negative 3 pi by 4i. Find the two square roots of u, two square roots of u. Give an answer in the form this, where r is greater than 0 and giving your exact values of r and theta. Now this question may feel confusing at first, but it is the simplest question. Don't worry about it. Let me teach you how to deal with questions like this. Now, first important thing is that we have to use our answer to part B. So u equals to 2 e to the power negative 3 pi by 4i. This is the case. Yes or no? Tell me. All right. Now, this is the number which we have, 3 pi by 4, and we want to calculate the square root of this number. Two square roots of u. Okay, so we have to calculate two numbers which multiplies to get this number, right? Two numbers which multiplies to get this number. So the first number, let the first number be ei theta. The second number will also be same numbers will be multiplied to get this number. Think of the idea which I am getting. Are you getting the same idea or not? So e to the power I theta. Yes or no? Yes, sir. Now what can we do next? We know that it would become negative 3 pi by 4 iota equals to r square e to the power I theta 1 plus theta 2. Yes or no? And that would become 2 theta. Theta 2 theta. Yes or no? Now we will equate r square equals to 2, r equals to square root of 2. Yes or no? Tell me yes or no. I just want to ask yes or no. Or 2 theta equals to negative 3 pi by 4 and theta equals to negative 3 pi by 8. Yes or no? Will this be the case or not? Yes, sir, this will be the case because it is twice. Okay, so this is first solution which we have. The first solution is that the number could be solution 1. Why am I calling it solution 1? I will tell you. I will tell you why I am calling it solution 1. Don't worry. Just believe me. The solution 1 is r is root 2. So root 2 e to the power I. And what is the value of nu theta? Negative 3 pi by 8. Now let us try to figure out the second solution. What is the second solution? So if our point was here, right? We have calculated the angle in the clockwise direction. What was the need of calculating it in the clockwise direction? The need was because the range of theta was negative pi to pi. Yes or no? Yes, sir. But over here, if we look closely, twice theta equals to theta. What am I saying? Twice theta. Think about it. If I move in the anti-clockwise direction and find this angle, which would be 5 pi by 4. Think with me. So this 5 pi by 4 equals to twice theta. Are you thinking with me or not? This 5 pi by 4 equals to twice theta. Now if I calculate theta, that would be 5 pi by 8, which is still in the range. Which is still in the range, A-level students, which is still in the range, which would be somewhat here. Yes or no? 5 pi by 8? 5 pi by 8? Yes or no? Tell me that first. Yes or no? Just speak yes or no. Yes. Very good. So it is still in the range. So we will take this also as a solution. So our two answers, solution 2 would be square root of 2 e to the power 5 pi by 8 and iota. If you missed one of this solution, your marks will be deducted. I hope you understood this concept. Very good learners. Thank you for making it this far. Now let's jump on to the next topic, that is Argand diagram and loci. On a sketch of an Argand diagram, shade the region whose point represent complex number z satisfying the inequalities z minus 3 minus iota less than equals to 3 and mod z is greater than equals to mod z minus 4 iota. First thing is that we have to interpret what is this equation. I can interpret it from this one, that this is a circle and this one is of a perpendicular bisector, right? One more important thing while drawing Argand diagram, you have to be precise. Use your ruler, you won't get a graph. Okay? So you have to be a precise, you have to draw a precise diagram of an Argand diagram by using your ruler and just mark these points like this. Be 100% precise, otherwise your marks will be deducted. Okay? We have to draw a circle. First of all, the equation of circle is not in the proper format. Let me write it in proper format. Take negative common, then it would become 3 plus iota. If negative is outside, the sign changes. 3 was negative, it will become positive. And iota was also negative. It will become positive mod less than equals to 3. What can you see from this? That the center of the circle is at 3 and 1. These are the coordinates of the center. And the radius is 3. So we will draw a circle with the center at, we will draw a circle with the center at 3 and 1. This is 3 and 1. Somewhat like this. I will draw freehand from now to don't waste time, but you have to be precise and use your compass. Okay. Now we have to draw a perpendicular bisector now. So what are the first coordinates? You tell me. The first coordinates are 0, 0. Can we see it from here or not? So the first coordinate is this, and the second coordinate is 4i, that is 4. Why, sir? Why 4i? We can see negative 4i. No, the form was this, right? Z minus z1 is greater than equals to z minus z2. Okay, so if we compare it, the coordinate would be 4 iota. That would be somewhat here 4. If the radius is 3, it would be above it. Yes or no? If this radius is 3, 4 iota would be above it. This is 4i. This is 0. We will draw a perpendicular bisector. The perpendicular bisector will go through 2i. 2i would be somewhat here. Yes or no? Perpendicular bisector will go from here because the bisector means half. This is 2i and this is also 2i. You can draw a perpendicular bisector by your compass. How can we do that? Put the compass needle on this, draw an arc, then again here, draw another arc, then again on this point, draw an arc, again on this point, draw another arc, and then join these. You will get a perpendicular bisector. Okay? Very good, learners. Now let's shade it. For the circle, if it is less than equals to 3, then the complete part will be shaded. Will it be or not? Tell me. Will it be or not? Yes, sir, it would be. Now for the perpendicular bisector, see this point, this region is showing greater than. Always shade towards the less than region. Okay, towards the less than. Can you see this sign? Always shade towards which the point is facing. So I will shade towards here. So I will shade this region. I'm using a different color. Very good. Now, which region is common between these two? This region or not? See, this is a common region where lines are intersecting. So, in the final answer, we will shade only this part. Okay? Are you imagining it with me or not? Our required region was this one. Very good, learners. You got this one correct. But a question arises, sir, why are we shading the region towards here? Why not towards here? That brings us to the definition of modulus. What do you mean by this? What do you mean by this term? We have to find a point whose distance from this point is 2. Let me repeat it again. This is the definition of modulus. We have to find a point whose distance from 3 is 2. So, what is the answer? If I get a point 3, 3 is somewhat here. Now, I need a point whose distance from 3 is 2. So, we will have two answers. We will get 5 as well, and we can get 1 as well. Yes or no? To get, because see, we need a distance, right? Distance is both sides. This is also 2. See, this is also 2. And this is also 2, irrespective of sign. So if we try to solve this, equals to 2 and x minus 3 equals to negative 2, which will give us x equals to 5 and x equals to 1. This was the definition of modulus. Let us bring the definition back into this perspective. So we have to find the value of z. We have to find a region whose distance from z1, that was this one, okay, is greater, any value whose distance is greater from O but less than 4i. Greater than O but less than 4i. Perpendicular bisector has divided this into two parts. This is part 1, this is part 2. Any point over here will have a distance from O smaller, from Z1 smaller than Z2. Imagine it. Any point over here. Any point over here will have a distance with Z2 lesser than Z1. Are you thinking or not? Are you sitting like that only? Open your notebook, open your pen, and think like a mathematician. I command you to do that. Let's go. Very good. This is the reason why we are shading towards the less than part. Understood? That's all for today's videos, learners. Next is the last part of complex number, in which we will discuss more questions like this. See you in the next video.